Alright, hello. Um, I thought I'd show off my engraving setup. I haven't gotten that far with learning the actual engraving yet, but I thought I'd start with the tools. So first off is the machine itself. This is, I'd like to say it's pretty standard as homemade engraving machines go. I've been looking at lots of the work that Shaun Hughes has put out on YouTube, and this is pretty much his machine. It's pretty much his setup. Maybe someone was before him, I don't know. I've used him as sort of an inspiration, and he's also been very helpful with questions, and he's been very detailed in his description. So check out his videos on how to build one. I'm not going to go into that much detail. I'm just going to tell you what's inside mine. I fit it all inside a plastic box. This is just a general storage box from a hardware store. It has a 12-volt PC fan with a hole cut out for it, so I can get proper air circulation. It has vents in the top to keep the air flowing. The power supply has its own fan as well, so that keeps the air flowing from the outside up. There's a power supply, I mentioned that. This is a second-hand PC power supply, and it's very useful because it has several outputs. So I can get 5 volts, I can get 12 volts, positive and negative. I saved a bunch of the cables in case I want to add extras later on. The compressor is the very same that Shaun uses for his machine. This one has a manometer and it has, I don't know, some add-ons, and they're completely useless for this. So if you happen to find one without all this, since I'm not outputting any actual pressure, I don't have any pressure buildup. The modification to the compressor makes it so it's both pushing air and sucking air. Check out Shaun's video for that again on how you can make that modification to the actual piston. I press fit and Loctited in with cylindrical lock a nozzle in the cylinder head that connects this 5mm tubing. It's just regular PVC tubing. I have a 12-volt speed controller. The packaging for the compressor says that it runs on 12 amps maximum. So you have to have a pretty hefty speed controller with a fuse that can handle it in order to run 12 volts through it. This one I think is rated up to 15 amps, but the starting power for a compressor such as this, when an electrical motor is standing still and you want to start it, there can be a spike current, so you might blow a fuse. Luckily this one works. It was kind of a long shot, but it works. Yeah, that's about it for the inside. This is an optional tubing. I'll mention that later. So snap it back up. On the side of it I have the knob for the speed controller and the switch for the compressor. Yeah, so let's move on to the handpiece, which is probably the only real news. I haven't seen one of these, a build like this on YouTube or anything. Maybe there is one out there. Feel free to point that out to me if that's the case. I could use more inspiration on building these. This is a palm control graver for an engraving machine with an oscillating air pillar. There is a handpiece that's sold commercially with the palm control. It's called a Lindsay palm control air graver, and that one uses only compressed air and has a different principle for the oscillating piston. This one I built from a hydraulic coupling. That's the base components, this here and this here, and also the collar that I've pressed into this wooden handle. It's pressed in there with some heat shrink, and it's actually keeping a pretty nice airtight seal. This is a knob from a drawer that I just got from a second-hand store as well, thrift store. I made some components. The cylinder I made from brass stock. This is just a washer. well, a nut that I've turned down, and I made my own quick fit tool holders as well, or holder. At the moment I'm going to make more of these. The square gravers turn out to be a hassle to fit in there, so I'm going to make them for round carbide inserts. This is just a furniture button as well. The way it works, I'll hook it up to the machine and I'll show you. So the way this works is, if I push on the back of this, I open the airflow to the piston and the handle starts operating. The harder I push, the more air I let through, and the harder the action at the actual graver. So let me take it apart for you so you can see what's going on. Right, so this is the holder for the tool holder. This is not optimal. This screw that I'm doing right now, this is a screw that fits onto a flat here, but every time I'm running the handpiece dry, so to speak, meaning that I don't have any load on the graver tip, this one will vibrate back and forth and it will work up a lip here. So I think I'm going to make a spring-loaded design for that, to just keep a ball bearing pressed into this recess, so that I can actually pull it out if I need to, but just so that it stays in place if I happen to touch the handpiece and it starts vibrating, or the piston starts hitting with nothing to engrave. This is a just mild steel tool holder where I soldered on a guiding pin that fits into a recess here. It's all pretty standard. And here is my piston. It's a lot smaller than most I've seen. I've actually never ever held a commercial air graver. I've just seen drawings, I've seen people using them on YouTube. I've never held one before, so this is just my idea of how one might work. So this is a hardened, polished piston. There's a little bit of oil on there. I think it comes from the compressor. So this is hardened to a pretty high hardness. I think I made it straw when I tempered it. That fits into this cylinder. The cylinder bore was reamed out using some steel rod that is the same steel rod that the piston was made from, so it's a pretty tight fit. It's a sliding fit, but it's yeah. I also polished it up a bit afterwards to reduce friction, and that also left some space in there for it. I think also that a little bit of air leak, I'm not losing significant power due to it, but a little bit of air leak I think makes for a cushion of air between the cylinder and the piston, and that actually helps lubricate it somewhat, like an air bearing. That's just a thought. I don't know if it's accurate, but I haven't noticed anywhere so far, and I'm not oiling this piston, so something is keeping it running smoothly. I think it's like an air cushion. This is just a spring that I modified to fit over the plunger that I'm going to show you. So this is a return spring. It's set pretty tight at the moment. It's actually making sure that the piston is contacting the tool holder at all times. I think if I back this spring off or cut it a bit short, I might be able to get a bit more power out of it. That's not been an issue so far though. So for this is this is what I'm holding now. This is the regulating mechanism for the airflow. So this is what sets my handpiece apart from other handpieces that have a foot pedal, which clamps down on the tubing. So let me take this apart. Okay. That's all there is to it. This is combined with this, I've modified them somewhat. There used to be a sort of snap fitting here, and the part that I pressed in here used to be arranged in the same way with a spring. This is a spring, this is a very crude spring, but unfortunately this was the one that works the best, so it stays in there. So there used to be ball bearings in here, or sort of balls that would press out to snap fit these two together. So this is a hydraulic coupling. This is for anyone wanting to make the same project that I've done here. This is a Parker BST1 brass hydraulic coupling. I modified the threads. I think they used to be like an 1/8" NPT thread. I think it's a tapered. So that was a bit of a hassle. I live in Sweden, so we don't I wasn't too familiar with the NPT system, but turns out they had the taps and dies at the local hardware store. I found that out after I modified them. I actually even made inserts so that I could modify them. So I soldered in, or brazed in an insert to make the thread usable. So that's for that. This is an original part that I manufactured, and this is kind of, this was the trickiest part to get accurate. Let me see if I can focus here. Yeah. So this is a plunger. I'd like to say it's a prototype because it's pretty crude, but it actually works pretty well. So this is a steel rod, and it's threaded on this portion, and I brazed on a brass disc that I then turned to a radius on the inside, and I ground that radius to fit the inside of this, so that when I drop this in, this actually produces a pretty much airtight seal. Combined with the spring load, the spring fits over here, and this is fitted to the furniture button in the back of the handle. That means this spring is always pushing the system shut tight. So when I push on the handle, the plunger lifts inside, and I also have these flutes. Now I'm not really sure that they were that necessary, because I noticed that the amount of travel that I needed in order to actually get sort of a high resolution to my like the palm control, it was so minute that I don't actually think they have any role at all. But they were milled at an angle in order, and they are tapered so that the further you push in, the further the opening for the airflow will be. But as I said, the travel at the moment is like a millimeter, so I don't think they play that big of a part. So that's the way it works, and I will show it to you in action in a moment. I just have to reassemble it. Before I do that, I thought I'd go over my engraving vise. That's also homemade. I do realize that most of these things could probably have been easier solved, or like they would perform better if I just went out and bought one. But as I'm sure many of you are familiar with, engraving stuff is very expensive, and I also like to make stuff, so well, that wasn't a very tough nut to crack to me, which way I wanted to go with that. Alright, so I ran out of space on my camera, and I had some focusing problems and the lighting kind of sucked, so I had to do another recording of this. This is my engraving vise. This is also shop made. It's based on a bowling ball that a local bowling alley was kind enough to give me, actually. I have a spare one if this one should ever break. I don't think that will be an issue. On it is mounted a Lazy Susan bearing that I got on eBay. It's a large diameter bearing with ball bearings in between. It has some play in it, but so far that hasn't really been a problem. On that I've made two wooden discs. One wooden disc that is directly mounted to the bearing. The other disc is notched, and it acts as a nut. And it actually has a nut at its center. Below here there's a carriage bolt going through up to the vise, and this is a positioning vise, meaning I can loosen this bolt and I can move the location, the center point of the vise, or the clamping head, which is the vise, I guess, around on the plate, so I can change the center of rotation depending on where I choose to position this, and then I just tighten it up and it stays in place. This is kind of roughly finished at the moment. It needs some sanding and some treatment, and in order to do that I need to take it apart. So I'm going to Loctite this down with thread lock, which will hopefully keep it in place for what I need to do with it. You can see the slot in which the bolt runs. Underneath that is a recess that is cut out for a washer that provides the support for the bolt. And the clamping, the topmost, the actual vise is it's just an engraving vise, or like bead, gem setting vise, or a bead setting vise that I got off eBay as well. Just clamps like so. That's about it. The whole thing rests in a wooden bowl that I got from the same thrift store as the rest of the stuff, and it positions kind of nicely, just enough friction for what I need it for. I thought about doing a lower cut on the bowling ball so that it would provide me with a parabolic thing, so that I would maintain a constant focal point no matter how I tilted the vise. That would mean cutting the vise very at a very low point, and that would mean cutting off even more bowling ball than I originally did, and that was kind of painful to do. I did it with a handsaw and ended up chipping off the chunks of material that was left at the center. This is not the same material all the way through. You can sort of tell here that it goes from, I think this is some type of bakelite. It smelled like it when I cut it. This is a pretty old bowling ball. So I think it's bakelite, and then there is some sort of, I think it's a ceramic rubber mix or something, and that really dulled the blade and made it really tough to cut. I think there's probably a way better way to do this. This is just, I used tools that I had on hand. Yeah, so that's about it. So let me show you that the machine actually works. And I'm using I've done some cuts on this already. This is a copper plate that is tinned, which was very common with like it used to be like a presenting plate or like a dining plate, decorative, I think. And they used to tin these on the back. So that's another tip for you. If you need practice plates for engraving, you can head down to your local thrift store and see if they have some decorative copper plates. They're usually very cheap. So I'm gonna plug in the machine. So now I have the strike length said about 1 turn of the thread out, which is kind of what I normally do for this size of engraving. Tends to vibrate itself out sometimes. So there you have it. Some different patterns. Just to show off that this is a really crappy resolution. Is to show off that the palm control actually makes a difference for the depth of cut. You can also tilt the graver. You can see the lines where I used a very light touch and a heavier touch, and then I angled the graver. You can also get a very nice control for it for cutting tight corners. So that's about it. I have a thought that I might try to make a copy, more or less, like my own version of the Lindsay graver. With an oscillating piston based on just, it sort of works like a steam engine with a constant supply of pressurized air. That's probably going to be a bit into the future though. But I really enjoyed making this one. It's been a project this spring, and I think it turned out very nicely. I'm learning as I go along, and I already realized that there are some improvements that I probably should make to it. I'm going to make the handle look a lot nicer, and I hope I can make another knob for it, another handle out of, well, preferably walnut or something. This was kind of boring actually. Well, I do hope you enjoyed this, and leave a comment or leave a question in the comment section if there's something you're wondering, and I'll answer it the best I can. Right, thanks for watching.